Hello everyone, welcome back to the channel. If you are preparing for generative AI interview in 2026 or you just want to understand the core concepts of Gen AI, this video is exactly what you need. Today we are diving deep into the six most important generative AI interview questions, from understanding what Gen AI is all about to transformers, LLMs, prompting strategies, tokenization, and encoder-decoder architectures. I have also created custom AI generated visuals for each concept to help you grasp these ideas faster. So grab your notebook and let's get started. Let's start with the foundation. What's the difference between generative AI and traditional AI? Traditional AI is like a smart calculator. It's designed for specific tasks like classification, prediction, or pattern recognition. Think spam detection, fraud detection, or image classification. It's reactive and follows predefined rules. Generative AI, on the other hand, is creative and proactive. It doesn't just analyze data, it creates new content. It can write stories, generate images, compose music, or even code software. Generative AI uses models like transformers and diffusion models to understand patterns and generate novel outputs that didn't exist before. Traditional AI analyze data, identify patterns, and make predictions or decisions. Generative AI generate new original content that is similar to the training data. Traditional AI uses learned pattern to classify, predict, or recommend outcomes based on the input data. Generative AI learns the underlying distribution of data and generates new samples from that learned distribution. Traditional AI learning approach supervised, unsupervised, or reinforcement learning on labeled or structured data. Generative AI learning approach typically unsupervised or self-supervised learning in large, often unstructured data. Traditional AI task specific and limited to what it was trained to do. Generative AI highly flexible and can adapt to a wide range of creative and complex tasks. Traditional AI finds patterns to make sense of data and produce outputs. Generative AI learns pattern to create a new data that follows the same pattern. Traditional AI typical applications, spam detection, fraud detection, recommendation systems, demand forecasting, etc. Generative AI applications, text generation, image generation, music composition, code generation, design, content creation, edition. Technologies for traditional AI is linear regression, decision trees, SVM, random forest, XGBoost, CNNs for classifications, edition. Models for generative AIs, GPT transformers, DAL-E, stable diffusion, GANs, VAEs, diffusion models, LLMs, etc. Traditional AI helps machine make better decisions, where generative AI helps machines create new possibilities. Simple analogy. Traditional AI is like a photographer who captures what exists. Gen AI is like a painter who creates something new from imagination. This is why Gen AI is revolutionizing industries. It's not just automating tasks, it's creating possibilities. Next up, explain the transformer architecture at a high level. Transformers are the backbone of all modern Gen AI models, including GPT, Llama, and BERT. Introduced by Google in 2017, they revolutionized how AI processes languages. At a high level, transformers work like this. Input embedding. Text is converted into numerical vectors that the model understands. Self-attention mechanism. This is the magic part. Each word in a sentence looks at all other words simultaneously to understand context. For example, in the transformer architecture is incredible. Attention helps the model understand that the at end refers back to transformer. Position encoding. Since transformers process words in parallel, not sequentially, they need to know word order. Encoder decoder stacks. Multiple layers of encoders process input and decoders generate output. The final layer produces prediction or generated text. Why transformers are revolutionary? Parallel processing faster than old sequential models. Context understanding, each word sees all others. Scalable, can grow to billions of parameters. Simple analogy. Think of a transformer like a team of experts discussing a sentence together, where everyone hears everyone else's input simultaneously. rather than reading word by word in order. What are LLMs? Large language models. LLMs are massive AI models trained on vast text datasets to understand and generate human language. Think ChatGPT, Llama, or Gemini. Key characteristic of LLMs scale billions to trillions of parameters. Training self-supervised on internet text. Capability understand, generate, translate text. Architecture built on transformer. Examples GPT-4, Llama 3, Cloud 3. How LLM works. Pre-training learn from massive text corpora, books, website articles. Pattern recognizes. Learn grammar, facts, reasoning, style. Generation. Predict next word token based on context. Types of LLMs. Encoder only, BERT for understanding task. Decoder only, GPT for generation task. Encoder decoder, T5 for translation summarization. Simple definition. LLMs are like superpowered language engines that can read, write, and understand text at human level. Now let's talk prompting strategies. What's the difference between zero shot and few shot prompting? This is critical for using LLMs effectively in real applications. Zero shot prompting definition asks the model to perform a task without any example. Prompt like a classify I love this. The model just uses its trained knowledge to answer. Based for simple task, generation knowledge, questions. Few short prompting definitions. Provide a 1 to 5 examples in the prompt to show the model what you want. Examples I love this, positive. Hater, negative. This is awesome, positive. The model learns from examples in the prompt. Based for complex tasks, specific formats, nuance instruction. Use zero sort for quick questions, few sort when you need precise control over output for. What is tokenization? This is fundamental concept every Gen AI engineer must understand. Tokenization is the process of breaking text into smaller units, tokens that the AI model can process. How tokenization works? Text I love AI. Tokens I love AI. Token IDs 123, 456, 789. Vectors 0.25, 0.45. Why tokenization matters? Models can't process raw text. They need numbers. Efficiency minus smaller tokens equal to faster processing. Context window limited by number of tokens 8K to 128K. Modern models GPT Llama uses server tokenization like byte pair encoding. Simple analogy. Tokenization is like breaking a books into paragraphs, then words, then letters. So the AI can read it piece by piece. Final question. What's the difference between encoder and decoder? This is crucial for understanding how transformer works. Encoder processes and compresses input into representations. Decoder generates output from those representations. Encoder reads entire input, creates context. Decoder generates output one token at a time. Simple roots. Encoder understand, decoder generates. That's it for today's generative AI interview question answer series. We covered Gen AI versus traditional AI, transformers at high level, what are LLMs, zero shot versus few soft prompting, tokenization, encoder versus decoder. If you found this helpful, hit like buttons, comment your questions below, subscribe for more Gen AI content, share with someone preparing for interviews. Thanks for watching, and I will see you in the next one. Keep learning and good luck with your interviews.